Hello everyone, my name is Manas Milind and welcome to another session of Learn Maths with Milind. Today we are going to learn integration by substitution. This is considered to be one of the complex methods of integrating, but once you learn it becomes simple. So let's see how do we do it. The first question arises, when do we do it? So technically when you don't see other methods that can be applied to this question, or if the question is not getting integrated using any other methods or simply the basic principles, then most probably this is going to be done by substitution. Another hint is if you see that by differentiating some part of the integral, we get the other part, then 100% it is of substitution. For example, here we have taken a question. Now this is called the integral. When you differentiate log x, we get 1 by x. So this is what I meant by when you differentiate one part of the function, you should get the other part. Now, before you start this, make sure you know some basic differentiation and general substitution. Why general substitution? We'll see this in a bit. Okay, let's get started with the question. So, first thing I've written ln x. Now, people who are wondering why ln x, why not log x? Because in calculus, the base of log is e. So instead of writing log e, we can only write ln. ln means simply log e. Now let's get started. So step 1 says assume a part of the integral to be t, which on differentiating gives the other part. So this is your main step where you have to check or assume what will be your t. I've taken a simple question to explain the structure, then we'll do one complicated question or little complex question. So it's clearly seen that when you differentiate log x, you will get 1 by x, which is the other half. So we will take this ln x to be t. So let ln x is equals to t. Then you differentiate both sides with respect to x. So differentiating with respect to x on both sides. If you want to write it, write it. If you don't want to write it, don't write it. This is not important, but you should know why, what, with respect to what you are differentiating. That is important. So when you differentiate log x, you should get 1 by x. And some people have doubt, what do I get when I differentiate t with respect to x? You will get dt by dx, because d by dx is nothing but a representation of differentiate with respect to x. So if you are differentiating t, simply write dx, d by dx of dt. Now transfer the dx on the other side by cross multiplication. So we'll get 1 by, let me do this on the next page. We will get 1 by x dx is equals to dt. This is our first step. So you have to say, assume a part of the integral to be t. Okay, and we are going to call this as equation 1. Why are we using it? We'll see in a bit. Done. Now, step 2 says differentiate equation 1 with respect to x on both sides. We have already done this. We have differentiated with respect to x on both sides to get this function. Third step says using equation 1, which is this, and the differential equation. Why differential equation? Because this equation contains derivatives. Those equations will be called differential equation. Replace the integral function, that is this or this, from x into t variable. So wherever you see x, you should not see x now, you should see t. How do we change it? Let's see. I'm going to color code it to make it look easy. Now we have 1 by x as dt. So let me show you. Can we rewrite our function as, or integral as, integral of ln x in bracket 1 by x. Okay, I'll not write this because it generally confuses that 1 by x is a log. So 1 by x bracket ln x dx. Now if you see, we have got our 1 by x dx as dt. So this is what we mean by replace the integral function from x into t variable. This is called substitution, And that's why the name is by substitution method. Integral of, so 1 by x dx becomes dt. And what about this ln x? Ln x has already been taken or assumed to be what? T. So you will replace ln x with t, and that's it. Now your integral becomes t dt. And if you're wondering why I can't solve this question with any other technique, you can check and apply. Any other thing will not work, right? Okay, so let's see. Now t dt. So that's it. Your equation step 3 is done. Step 4 simply says integrate and replace the t into x variable again. So let's integrate first. This is pretty simple. Integral of t dt will be t square by 2 plus c. And the last step, and the most important, people forget this, replace the original function, because the question was asked in x variable. It wasn't asked in t variable. So what is t? T is nothing but ln x. So substitute ln x back in place of t. That will be our answer. Okay, so pretty simple, right? This is a simple question, but it's not that simple. Let's see another question which is a little more complicated. So let's take question number 2. This says integrate x plus 1 bracket x plus ln x whole square whole divided by x dx. Right, now this is our question. So if you go by step 1, it says assume a part of the integral to be t, which on differentiating gives the other part. In this question, you will not see it directly, because if you, let's say you take this function and you differentiate it, you will get 1 plus 0. If you take this bracket, you differentiate, you will get 1 plus 1 by x. So 1 by x is there, but 1 is not there. So what do we do? In this question, or in a lot of questions, you need to simplify or change your expression to look like something else. How? See, we differentiated this, right? We know that, okay, if I differentiate ln x, I will get x, 1 by x. But what about these variables? So it's not looking good. Then we thought, okay, now I'll tell you a trick. In substitution questions, most of the times, the expression which has a power on top is generally taken to be t. So if nothing works, you do one thing. You take it to be t. We'll see what happens. We'll take let x plus ln x to be t. Step 2, differentiating with respect to x. So I'm just putting with respect to x on both sides. What do we get? X becomes 1, ln x becomes 1 by x dt by dx. Transfer the dx to the other side, we'll get 1 plus 1 by x dx is equals to dt. Now let's see, we will change, or using step 3, we will replace our variable from x into t, whatever is possible. Let me rewrite this. We have x plus 1. In bracket we have x plus ln x whole square divided by x dx. So color coding again, because it's a little tricky in the beginning to see what is being replaced. 1 plus 1 by x dx is equals to dt. We don't know that, but we know that x plus ln x whole is nothing but t, right? So this was our equation 1. We know that x plus ln x is t. So you replace t over there. We'll do this step by step. We'll not hurry up. So x plus 1 t square divided by x dx. We have still not used this equation. So let's see, can we change whatever is left and use this? If we closely see, we can actually do it. All you have to do is put this differential as a part of this bracket. So see, x plus 1 by x t square dx. So right now it doesn't look like it's gonna replace, right? So what do? We change or we divide. We perform a split division. So x by x plus 1 by x t square dx. Then you cancel this x and x, you get integral of 1 plus 1 by x t square dx. Now you see that yes, we can use 1 plus 1 by x dx in place of this function, and that's it. You replace it again, so we get dt, right? So this entire yellow expression becomes dt, so you get t square dt. That's it. Step 4, integrate, so you get t cube by 3 plus c, and then replace your t from equation 1, which is x plus ln x, back in the final answer. So x plus ln x whole cube by 3 plus c. That is our answer. Okay, so that's it, guys. Hope you would have understood by substitution. If you like the video, if it helps you, please comment, subscribe, and please share it with your friends. Thank you for watching the video. I'll see you again soon. Bye.